Hello, Namaste. Welcome to this channel, Chemistry Made Easy by Dr. Ashok, Mulik. Today we will discuss the remaining part of general characteristics of ionic solids, which is under this ionic bonding and structure. So today the points of interest, that is the remaining general characteristics of ionic solids, are like this. So these are points of interest. So one is ionic reactions. We know the ionic solids, when dissolved in water, undergoes ionization. As a result of this, the ions present in the ionic solid are split or dissociated into ions, and these ions can undergo reactions with any other ions of ionic nature when they are soluble in water in the form of another solution. For example, if we carry out reaction between aqueous solution of HCl and aqueous solution of NaOH, then we can have the reaction like this: HCl aqueous plus NaOH aqueous gives NaCl plus H2O. So here the ions of HCl, it is H plus and Cl minus, are coming into the ionized state. NaOH also gets ionized into Na plus and OH minus. And in such aqueous solution, the Na plus reacts with Cl minus and gives NaCl, whereas this OH minus reacts with this H plus and gives H2O. So there are such type of number of reactions which can be carried out in aqueous solution and which are showing the existence of ionic solid in the form of ions. Then next point is isomorphism. This is isomorphism. What is isomorphism? It is the formation, it is the phenomenon in which ionic solids are formed in the mixed form, where the ions of similar size or molecules of similar size can replace each other. So one type of ions or molecules can replace the ions or molecules of other form, and this gives a mixed ionic solid. This is called isomorphism. For example, if we see the example of NaF, where we can have the electrons here 8, here we have 10, and here it has also 10. Similarly, if we consider another example which can present here, that is MgO. So this Mg has also 10 electrons, and this oxygen has also 10 electrons. So these are 10 electrons each. So they are having same size, so their ions can mix with each other and give a mixed form of the ionic solid. So similarly, we can have another example of K2S and is calcium chloride, CaCl. So we can have also here similar type of observation of isomorphism. Now we will see the next example, next property, that is melting points and boiling points. We know that the ionic bond existing in the ionic solid is very strong, and in order to melt that solid or boil that solid, it requires very high amount of energy. So the energy is required for mobilization of the ions, and this is very high. If we consider the example of the NaCl, it has higher melting point, that is 800 degrees centigrade. 800 degrees centigrade. Whereas the ionic solid of similarly the same size of ions, that is NaF, and another solid, that is BaO. BaO has ions of same nature, but here Na is +1, Cl is -1. Here Ba is 2 plus O is 2 minus, and because of this the melting point is much different, much higher. It is 1921 degrees centigrade. So because of higher oxidation state of Ba and oxygen compared to Na and Cl minus, the melting point is much higher because the ionic bond is much stronger. Then we will see the solubility. Solubility, this point is still remains. Solvation energy, solubility is still to be discussed. Now so we will discuss this solubility. Ionic solids are polar in nature. We have seen last time that the bonds of ionic nature are polar. So such solids are easily soluble in polar solvents like water. Water is also a polar solvent. So when we add some salt to this polar solvent like water, then it gets ionized. This is because the solution shows that the solvation energy is much higher than the lattice energy of the solid. So ionic solid has lattice energy, and solvent has solvation energy. So in such a case where solvation energy is higher than lattice energy, the solvation of the solute, that is ionic solid, takes place. If the solid is for this type, the solid can be say NaCl, KCl, etc., or MgCl2, etc. So this solvation is better, energy is better than lattice energy. But if the solid has, if the solvent has solvation energy less, so we will see here solvation energy. When solvation energy less than lattice energy, then the solid will remain insoluble. So for example, barium sulfate, or we can consider barium salts, or we can consider calcium phosphate, Ca3PO4 twice. Or there are many such type of solids which can have the solubility less in water, that is calcium carbonate, AgCl. So there are several such examples which can show less solubility, or means they are sparingly soluble, means very less solubility, and these compounds are therefore said to be insoluble in water. So this phenomenon of solubility is observed. Isomerism was explained by this scientist Mr. Mulik. Now we will see that the next point, that is heat of vaporization. Heat of vaporization. These ionic solids have very high heat of vaporization. Heat of vaporization is very high. It requires more heat to get vaporization. Then vapor pressure of such ionic solids is low. Heat of vaporization is high and vapor pressure is low. Then if we see the elasticity, next property, these compounds, ionic solids, are much more hard and brittle. Therefore they do not exhibit elasticity. It means they have very low elasticity. They are not flexible. We cannot bend them easily. If we try to bend them, it gets broken. That is, it is brittle. Therefore, it is called the ionic solids having very low elasticity. So with this we have completed this point of general characteristics of ionic solids. Next time we will see the next point, that is Fuson's rules and their applications. So till then, goodbye. Keep watching this channel and sharing this channel with your friends so that they are benefited easily. Also try to press bell icon button and like button and subscribe to this channel. Thank you very much for sparing your valuable time.